Hello students, Namaste, welcome to grade 7 chemistry classes. In today's session we are going to talk about types of units of concentration. So in how many ways we can express concentration of a solution. So let us start our session with different units of concentration. Different units of concentration. As we have different units for weight and volume. Weight have different units like kg, gram, milligram, ton. In the same way, volume also we have different units, dm cube, liters, milliliters. Even we have concentration different units. They are strength, also known as gram per liter, molarity, mole fraction, parts per million, parts per billion, and percentage, weight by weight, weight by volume percentage, volume upon volume percentage. These are the different units of concentration. Now let us start with strength. What is strength of a solution? The number of grams of solute in 1 liter solution, known as strength of a solution. So strength is equal to number of grams upon volume of solution in liters. If volume of solution in 1 liter, if volume is 1 liter, then S is equal to number of grams. Let us take one example. There is 2 grams of calcium carbonate present in 500 ml solution. What is the strength? What is the strength of solution? So strength is equal to number of grams 2 upon volume of solution is 500 ml. You have to convert volume in liter, so 2 grams upon 500 upon 1000. Then it is 2 upon 0.5. Can be written as 2 upon 5 upon 10 is nothing but 20 upon 5, 4. Now the strength of solution is 4 gram per liter. For 1 liter we have 4 grams of solute. So let us solve one more question. Try to solve one more example. A solution of strength 3 gram per liter. What is volume of solution in ml required? Volume of solution in ml required to prepare by dissolving by dissolving 6 grams of solute. 6 grams of solute. So here strength is equal to weight of solute upon volume of solution in liter. Weight of solute given 6 grams. Strength we need 3 gram per 1 liter. Then volume is X. Then X is equal to 6 gram per 3 gram per liter. So gram cancel, 3 2s are. Then we need 2 liter solution. So if you dissolve 6 gram solute in 2 liter, then we'll get 3 gram per liter strength of a solution. Now let us learn second type of concentration, that is percentage weight or percentage volume. Percentage weight or percentage volume. Here, what is weight by weight percentage? Weight by weight percent is equal to weight of solute in weight of solution into 100. So we can define amount of solute in grams present in 100 gram solution is known as percentage of solute, weight by weight. So if you take this formula, percentage of weight by weight is equal to weight of solute can be written as WB. Let us take it as WB upon weight of solution is nothing but weight of solute plus weight of solvent, WB plus WA into 100. Now let us solve an example with this. Calculate percentage of solute weight by weight when 18 grams of sodium hydroxide NaOH dissolved in 200 grams of solution. So here percentage is equal to weight of solute given 18 grams, weight of solution given 200 into 100, 2 zeros, then it is 9%. Grams cancel, then it is 9%. So solution percentage is 9%. Now solve one more question, students, based on the same concept. What is the volume of solvent? What is volume of solvent required to make 20% solution of calcium carbonate of total weight 400 grams solution. So what is the weight of calcium carbonate or solute which is required to make 400 grams of solution? Here percentage is 20 is equal to weight of solute X upon 400 into 100, cancel, and X is equal to 20 into 4, that is 80 grams. So X is weight of solute. Now what is a solvent weight? What is a solvent weight? We got weight of solute WB. Now WB plus WA is equal to weight of solution, that is 400. Now WA is equal to 400 minus WB. So 400 minus 80, that is 320 grams of solvent must be taken. Hope it is clear. So we have learned about strength and weight by weight percentage. Now let us learn what is volume by volume percentage and weight by volume percentage. So next concept. Volume upon volume percentage. Here volume of solute upon volume of solution into 100. So previously we have measured the solute and solvent in weights. Now we are measuring the solute and solvent in volumes. Nothing but you can take it in mLs or liters. So preferably we take it in ml. Here we can define the volume of solute, in 100 ml solution is known as percentage volume upon volume solute. Let's take simple example. I have dissolved 10 ml solute in 100 ml solution. Then percentage volume by volume is equal to 10 upon 100 into 100, that is 10%. That means 10% is nothing but 10 ml in 100 ml. Now in case if you take 200 ml solution, 5% concentration, 5% volume upon volume concentration. Then what is the weight of solute? What is solute volume? Sorry, not weight, solute volume. Here percentage is 5 is equal to volume of solute VB upon volume of solution V into 100. So 200 ml solution, 5 is equal to VB upon 200 into 100, cancel. Then it is VB is equal to 5 into 2 is nothing but 10 ml. So we have to dissolve 10 ml of solute in 200 ml, that is equal to 5% volume upon volume. Hope it is clear. Now let me give you one more question. 20 grams in 400 grams. Then what is the concentration of solution and which units we have to use? 20 grams in 400 grams. Both are in weights. Then it is weight by weight percentage. Weight by weight percentage. That is 20 upon 400 into 100. That is 5%. Weight by weight. 5% weight by weight. Now same thing, if you take volume 20 ml in 400 ml, we'll get 5% volume upon volume. So in this case we have both are in volumes, this case we have both in weights. Finally we can take solute in grams, solution in volume. Then we call it as weight by volume percentage. This is the number of grams of solute in 100 ml solution. number of grams of solute in 100 ml solution is known as weight by volume percentage. Now if you take 20 grams in 200 ml solution, 20 grams in 200 ml solution, 20 grams in 200 ml solution, then it is taken weight by volume percentage is equal to 20 grams upon 200 ml into 100, then it is 10 gram per ml percentage. This is weight by volume percentage. So what is molarity? Molarity represented by capital M is nothing but number of moles of solute, number of moles of solute in 1 liter solution, number of moles of solute in 1 liter solution. So capital M is equal to N by V in liters. Here N is number of moles of solute, V is volume of solution, and if 1 mole dissolved in 1 liter, then we call it as 1 mole per liter or mole liter inverse, and this we call it as molar. This we call it as molar solution. So 1 molar means M is equal to 1, we call it as molar solution. If M is equal to 0.1, we call it as decimolar solution. If it is 0.01, centimolar solution. If it is 0.001, millimolar solution. Millimolar solution. And if it is 0.5, then we call semimolar solution. Semimolar solution. So based on molarity, we can call solution in different names: molar, semimolar, millimolar, decimolar, and centimolar. Now M is equal to N upon V in liters. What is N? Number of moles of solute. Number of moles of solute is nothing but weight of solute upon molecular weight of solute into 1 by V in liters. Also can be written as weight of solute upon molecular weight of solute into 1000 by V in ml. So this is molarity. Sometimes we can use this formula and sometimes we can use this formula to calculate. Now let us solve few questions based on molarity. Question number 1. Calculate molarity of solution in which 4 grams of NaOH present in 500 ml solution. Here the volume given in ml, so we can use this formula directly. Molarity is equal to weight of solute 4 grams, molecular weight of NaOH 23 plus 16 plus 1, 23 plus 16 plus 1 into 1000 by 500. So it is 4 upon 40 into 1000 by 500. 500 2 times, 4 10 times, 10, this is 2 upon 10, 0.2 molar solution. The concentration of solution is 0.2 molar. Now let us start one more question. You try to practice with me. Calculate molarity of solution. calculate molarity of solution when 9.8 grams of sulfuric acid. Calculate molarity of solution when 9.8 grams of H2SO4 in 250 ml solution. So here molarity is equal to number of moles upon volume in liters. Here number of moles, weight by molecular weight. So N is equal to weight of solute 9.8 upon molecular weight of sulfuric acid 98, that is 1 by 10, 0.1, and volume of solution V in liters, that is 250 upon 1000, 0 cancel, 4 times 1 by 4. Now we can take M is equal to number of moles 0.1 upon 1 by 4 liters. That can be written as 0.1 into 4 upon 1 liter, that is 0.4 mole per liter or 0.4 molar solution. Is that clear? Right. Now let us solve one more question. Calculate molarity of 20% weight by weight sulfuric acid solution, H2SO4 solution of density 1.5 gram per ml or kg per liter. Calculate molarity of 20% weight by weight H2SO4 solution. Density is given. So weight by weight percentage given is 20%. That means 20 grams in 100 gram solution. 20 grams in 100 gram solution. Now weight of solution 100 grams, and so density is 1.5 gram per ml. Now D is equal to M by V. We have weight of solution, we have density. So V is equal to M upon D. The volume is equal to mass by density. Mass is 100 grams. Density is 1.5 gram per ml. Now 1.5 can be written as 3 by 2. So 100 upon 3 by 2 is nothing but 200 upon 3 ml. This is the volume of solution. Correct? So we have density, we have weight of solution, we found volume of solution, that is 200 by 3 ml. Now let us calculate molarity is equal to weight of solute upon molecular weight of solute into 1000 upon volume of solution in ml. So molarity is equal to weight of solute 20 grams, since it is 20%. Molecular weight 98 for sulfuric acid, 1000 upon volume of solution 200 upon 3 can be written as 10 times, 10 100 times, then we can write it as 1 by 98 into 100 into 3 upon 1. It is nothing but 300 by 98. We will get approximately 3.1 molar. 3.1 molar. This is nothing but molarity is equal to 3.1 mole per liter. Mole per liter. So this is how to calculate when they give weight by weight percentage, and we have to convert into molarity. Now let us learn molarity calculation when two solutions are mixed and a solution is diluted. So a solution concentration will vary when you change the volume, because molarity is N by V in liter. If volume increases, molarity decreases. But number of moles can be constant. We can write M1 is equal to N1 upon V1 in liters. M2 is equal to N2 upon V2 in liters. We have taken a solution, its volume is V1, and in that number of moles dissolved is N1. Now additionally, if you add more solvent, since it is diluted, we are adding more solvent, then we get a new solution of volume V2, but the number of moles N2, that is equal to N1 only, because number of moles doesn't change when you add solvent. Solute remains constant. Then what is the relation between M1 and M2? So M1 divided by M2 is equal to N1 upon V1 divided by N2 upon V2. Since N1 and N2 constant, N1 and N2 both are equal, so they'll get cancelled and it can be written as V2 upon V1. So M1 V1 is equal to M2 V2. The product of molarity and the volume remain equal or constant. Since M is equal to N by V in liter, so N is equal to M into V. Since number of moles constant, so MV becomes constant. Then M1 V1 is equal to M2 V2 is equal to so on Mn Vn. Same solution, how many times you dilute, the number of moles of solute in it will not change. So that is about comparing two solutions, the same solution when it is diluted and created new solution. Now let us solve one question based on this. Calculate concentration of solution prepared by diluting 500 ml 0.2 molar solution with 500 ml water. So initial molarity M1 is equal to 0.2, V1 is equal to 500 ml, then M2 we don't know X, V2 is initial volume V1 plus additional volume V additional, initial volume 500, additional volume 500, total it is 1000 ml. Now M1 V1 is equal to M1 V1 is equal to M2 V2. M2 is equal to M1 V1 upon V2. What is M1? 0.2, V1 500, V2 1000. 2 times 0.2 upon 2 is nothing but 1 by 10, 0.1 molar. So the volume is doubled, the concentration becomes half. Since the volume is doubled, the concentration becomes half, 0.2 to 0.1. Since the volume rises from 500 to 1000. Let's calculate one more question. Let's solve one more question similar to this. Calculate additional volume of water need to be added find volume of water need to be added to make a solution of 0.5 molar concentration to 0.1 molar if initial volume is 100 ml. Initial volume is 100 ml. So we have to find additionally how much volume must be added. Again, we have to use m1 v1 is equal to m2 v2. So here v2 is equal to m1 v1 upon m2. m1 is 0.5, v1 is 100 upon 0.1. We can take it as 5 times, that is 500 ml. So V2 is 500 ml. Then additional water, V2 minus V1, 500 minus 100 ml, that is 400 ml must be added additionally. Is that clear? Now let us learn how to find the concentration of solution when two solutions are mixed. Now this is the method we have to use when same solution is diluted. Next we are going to learn about when two solutions are mixed. Calculation of concentration of resultant solution when two solutions are mixed. Again, in that we have two types. Mixing of non-reactive solutions. So non-reactive solutions are mixed. Non-reactive solutions are mixed. That means I took a solution A of concentration MA, volume VA, and I have one more solution whose concentration is MB, volume is VB. You can take M1, V1, M2, V2 also. From this, we took volume of A and volume of B and we mixed both of the solution. Then we got a resultant solution. By mixing these two, we got a resultant solution whose concentration M. Then M is equal to total moles upon total volume. So how to find number of moles? Molarity is equal to N by V. Then M into V is number of moles. Then let us think it has N1 moles. Then N1 is equal to MAVA. N2 is nothing but MBVB. Then total moles N1 plus N2 is equal to MAVA plus MBVB. This is total moles. Then total volume is V1 plus V2 or VA plus VB. Then total moles MAVA plus MBVB upon total volume V1 plus V2, which will give you a resultant concentration. Let us solve one question based on this. The question is 0.2 molar HCl of 250 ml volume dissolved in or added to 0.1 molar 250 ml HCl. Now obviously both the HCls will not react because both are acids. What is the resultant concentration? what is resultant concentration? What is resultant concentration or resultant molarity? Then M is equal to MAVA. MA is 0.2, VA 250 plus MB 0.1, 250 upon 250 plus 250, that is equal to, we can write it as 2 into 25, 50 plus 25 upon 500. You can take it as 75 upon 500. Then we can write this into 2 into 2, 150 by 1000, 0 0 cancel, that is 0.15. Resultant molarity is 0.15. Let's check it. What we have done, we took MAVA plus MBVB upon total volume. So this is 0.2 into 250, 50, 0.1 into 250, 25 upon 500. So this is 75 by 500. I multiplied and divided with 2 and 2. Then we get 150 by 1000. So 150 by 1000 is nothing but 0.15 molar. Now this is how we have to calculate when non-reactive solutions are mixed. In case, what if in case the solutions are reactive? That means one acid and one base is mixed. One oxidant and one reductant is mixed. That means two solutions which are reacting are mixed. Then how to calculate resultant concentration? So calculation of resultant concentration when two solutions of reacting are mixed. So here non-reactive solutions, will make it as reactive solutions are mixed. Here let us think one is acid, one is base. This is acid, this is base. So same condition, 0.2 molar, 250 ml, HCl is mixed. It's 0.1 molar, 250 ml, NaOH. Now find out whose moles are more. First 0.2 molar, 0.1 molar. Obviously 0.2 molar is more. Then it will neutralize NaOH and remain with some amount of HCl. That means the resulting concentration will be acid solution. It have acid concentration only. So for that, resultant molarity is equal to MAVA minus MBVB upon VA plus VB. Here why we are subtracting? Because they are reacting with each other. So when you subtract, you should see always you should subtract higher moles to lower moles. Here number of moles of acid is more, so you can subtract acid minus base. If in case somewhere if base moles are more, you should subtract base minus acid. So let us solve the same question. So resultant molarity MAVA 250 into 0.2 minus 0.1 into 250 upon 500. Then it is 50 minus 25 upon 500. That is 25 by 50 into 10. 2 times, then it is 1 upon 20, 0.05 molar. The molarity of resultant solution is 0.05 molar. That is also acidic in nature. The solution is acidic in nature, since the number of moles of acid is more. So with this we have completed molarity, how to find molarity when two solutions are mixed, non-reactive and reactive, and a solution is diluted. Now let us find the relation between density and molarity. Density and molarity and percentage of purity. Density, molarity and percentage purity. So relation between molarity, density, weight by weight percentage. So molarity formula m is equal to weight of solute Wb upon molecular weight of solute Mb into 1000 upon volume of solution. It is volume of solution. Now D is equal to m by V. Here V is equal to volume of solution is equal to mass of solution upon density of solution. Now we can take it as V and substitute in equation 1. So Wb upon Mb into 1000 upon volume is nothing but mass by density. Mass by density. This is solution. This is also solution. Now weight of solute upon weight of solution. This D will go up and we can write it as Wb divided by Mb into 1000 into density upon mass of solution. This 1000 we can write it as 100 into 10. Now weight of solute by weight of solution into 100. This is nothing but percentage of weight by weight, percentage of solution. We can write it as percentage of solution into density into 10 upon molecular weight of solute. This is nothing but molarity. So we can say molarity is equal to 10 into percentage into density upon molecular weight. Let us solve one question based on this. So calculate molarity of 36.5% HCl of density 0.1 gram per ml. Calculate molarity of 36.5% HCl of density 0.1 gram per ml. Then molarity is equal to 10 into percentage is 36.5 into density 0.1 gram per ml upon molecular weight 36.5. These two will get cancelled. Then it is 10 into 0.1, that is 1 molar solution. So if the HCl has 36.5% purity and density 0.1 gram per ml, then the solution concentration will be 1 molar. So with this we have completed molarity. In the next session we are going to learn about normality and the relation between molarity and normality, mole fraction and the relation between molarity and mole fraction.